Welcome once again. Today we'll be dealing with Charles' law. We've already dealt with Boyle's law. Boyle's law was talking about pressure and volume. So today we'll be talking about volume and temperature of a gas. Now, Charles is a scientist that brought about Charles' law. That's why it was named Charles' law. He talked about how the volume has relationship with temperature of a fixed gas in a container. The volume of a fixed mass of gas is directly proportional to the temperature of that gas. Mathematically, we can see that the volume is directly proportional to the temperature. So if you remove our proportionality sign, we'll be having V is equal to KT. V is equal to KT. When you remove proportionality sign, you introduce a constant. The constant here is represented by K. So if I make K the subject of formula here, I'll have V is equal to K is equal to V over T. Let's assume this is my first equation. Let's assume we have two equations of the gas. When the gas moves from an initial state to a final state. So we'll be having, let's say, since I said initial and final, let's say this is my A1, B1, T1. And then the second state or the final state of the gas will now be K2 V2 over what? T2. But note that the constants of the gases are always equal. Since they are always equal, I can say that my K1 is equal to K2. That is, if this is K1 and this is K2, and this statement holds, that is, my V1 over T1 is equal to V2 over T2, because the whole of this is equal to K2 and the whole of this is equal to what? K1. So with this, you can say this is the formula for Charles' law. So they are directly proportional. When the volume of the gas is increased, temperature will definitely increase with increased volume. And when the temperature is decreased, the volume will also decrease. Let me use a practical example for you. Most of us that cook in the kitchen, you will notice that when you heat your pot and you cover it, when you heat it, the cover of the pot will tend to move because of the input of the heat. That is, your pot is trying to increase its volume because the temperature is being increased. So the temperature is trying to increase its volume. That is why the cover of the pot usually moves up. And then same thing, if you remove the heat, you will see that the cover of the pot will tend to come back and stay normal without moving. That is to say, when you increase the heat, there will be increased volume. When you decrease the heat, there will be a reduced volume. So that is Charles' law for you. And with the definition of this formula, this V1 so we're given a temperature, and the temperature is not in Kelvin, is in degrees Celsius. You convert to Kelvin before using it. And the formula you have to use, let me go this side of the board again. The formula you have to use when converting from a degree Celsius to Kelvin is that when I want to convert any degree Celsius number to Kelvin, I'll use the number of the degree Celsius plus 273. Let's say, for example, I want to convert 20 degrees Celsius to Kelvin. I will just add 273 to the 20 degrees Celsius. The final answer is my what? Temperature in Kelvin. Now, let's solve this question on the board. That a gas occupies 2 liters at 300 Kelvin. What will be its volume at 400 Kelvin? So now, like I've said before, if you want to solve a question, particularly calculation in chemistry, you try to bring out the variables from the question. Now they said a gas occupies 2 liters. Now liters is talking about volume. So definitely we have our V1 to be equal to 2 liters. At 300 Kelvin, we have our T1, that is the first temperature in the question. T1 is equal to what? 300 Kelvin. What will be its volume? Now we are asked, the question here is what will be its volume? So we don't know what is V2. So V2 will be a question mark. At 400 Kelvin, that is the second temperature, which is T2. Second temperature, 400 Kelvin. Now we all know the formula we are going to use. It is talking about V1, it is talking about volume and temperature. So definitely that is Charles' law. So now here we are going to make V2 subject of formula because we are looking for V2. We'll make V2 subject of formula. So here we'll be having V2, let me draw this. We'll be having V2 is equal to V1 T2 over T1. If you make V2 subject of formula from here, this is what we have. Then you try to plug in the numbers. You substitute. My V1 is what? 2 here. So 2 times T2. What's T2? My T2 here is what? 400 Kelvin. Divided by T1. What's my T1? My T1 is a 300 Kelvin. 300. So now I've successfully substituted all the variables. I can now go ahead and do my mathematics problem. So 0 here can cancel this one can cancel this. So we have 2 times 4. 2 times 4 will give me 8 divided by 3. 8 divided by 3 is going to give me a 2.6666, but approximately 2.67 liters. That is my V2. So the volume is equal to what? 2.67 liters. Now, let's go back to the relationship. Let's go back to the relationship of volume and temperature as given by Charles, or as given by Charles' law. He said the volume is directly proportional to the temperature. That is, when the temperature rises, there will be a volume increase. When the temperature falls, there will be a volume decrease. Now, look at this. They say a gas occupies 2 liters at this temperature. Now, look at what happened to the temperature. The temperature increased from 300 to 400. According to Charles' law, what do you expect to happen to the volume? The volume is supposed to increase. Now, look at the new volume we have. The volume increased 2.67. That means the volume increased by a 0.67 liters. So you can see that when the temperature increased, the volume will have to increase. Thank you very much for watching. This number 2 is as an assignment. Solve it, drop the question or drop the answer in the comment section. I'll be waiting for your answer in the comment section. Thank you very much.